This is going to be the video for chapter 3.4, which is on composition of functions. So we should probably define what a composition of a function is, or a transformation, I should say, not a composition of a function, but a composition of a transformation. So when you have two transformations done back to back or in sequence of each other, that's what we call a composition. Composition. Again, apologize for any misspellings here. So a composition of anything is simply a combination of two things. So a composition of functions is a combination of two functions if you when you take algebra 2. But a composition of transformations is when you have two or more transformations done back to back. Now, some of these have specific names, some of them don't. So like a glide reflection is a special type of composition. That's when you take an object like a footprint here, and then you reflect it, and then translate it. And if you do that over and over, reflect, translate, reflect, translate, you get this sort of step pattern, which is why it's sometimes called a step reflection as well. You get this sort of, let's say a glide or a swirl kind of situation here. You could also do it the other way. You could translate, if I do this in a different color here, it doesn't necessarily have to be in this order. You could translate and then reflect, translate, and then reflect, and you get the same sort of glide reflection, which is one of the unique properties about it, is that you can do these in any order, and you still end up with the same sort of glide reflection pattern. But again, not all of them have names. They don't need always names. All you need to know is what the base transformations are, and you can do the composition. So let's go here. Whoops. There we go. Sorry about that. So, some of the basic transformations we know of could also be done with compositions. Like, for example, this is a translation, right? I'm going to take a triangle and I'm going to slide or translate it to the other side. Well, I can do that with two reflections, right? If I make a line of reflection like right here, I could reflect this over that line, and then I can do another reflection over this line and reflect that way, and I get the same result. So I could get this result, moving it over here, by doing two flips. One flip this way and one flip another way. So a translation can be done using a composition of reflections. It's the same transformation twice, but still a composition because you're doing two or more of them. Same with rotations. And we kind of talked about this when we first talked about rotations. If I rotate something 180 degrees, that's the same thing as doing a reflection across the y and then a reflection across the x. If I reflect this twice in this manner, I get the same result as one 180-degree rotation. So this can be thought of as a composition of two reflections, which again, we normally don't think about that way, but it's helpful to know kind of how these things crop up in stuff that we've already seen. Now, normally what you're going to have to do is you're going to have to do a brand new composition. So I'm not going to necessarily have you, do 180 degrees as a composition of two reflections. I'm going to have you do something like this. So we have 3 points here, and I'm just going to give you 2 or 3 transformations to do. Now, the basic way of doing this is to simply just go one at a time and go through the list. So you start with A here, right, which is 3, 5. You're going to rotate 180 degrees. Well, rotate 180 means you're going to multiply both things by -1. So -3, -5. And then translate by 2, 1. So translate by 2, 1 means you're going to add 2 and add 1 to the x and y respectively. So that'd be -1, -4. And then reflect along the main diagonal. So a main diagonal reflection means you're going to swap the x and the y. So -4, -1. Right? So again, you just take it one at a time and you do it to each point. So I'm going to do the same thing to point B here real quick. Go a little quicker on this one because we know the basics here. So rotate 180 means I'm going to swap the signs, or reverse the signs I should say. Add 2, add 1, we get 0, 8. And then swap the variables, we get 8, 0. Again, just one at a time all the way through. Last one here, -5, 6. We rotate 180, so switch the signs. Add 2, add 1, which I'm not going to bother writing down there. So it'd be 7, -5, and then swap. We get -5, 7. Okay. So again, one at a time, all the way through. No big deal. That's what a composition is. If I give you like 10 of these in a row, all you do is just do one at a time, all the way through. No big deal. Just make sure you're especially careful on your signs, because flipping up a negative and a positive can be very easy if you're doing this in sort of a speedy fashion. Let's write another one here. -4, 1. we're going to reflect over the x. So reflecting over the x means I'm going to multiply the y coordinate by -1. So -4, -1. Rotate 90 degrees clockwise means I'm going to multiply the x by -1 and then swap the points. So this would be -1 comma +4. And then dilating means I simply multiply, so multiply by 2, so times 2 times 2, and we get -2, 8. And again, I do find it helpful to write out kind of what I'm doing on the bottom here, so that way when I do it to the other points, I kind of have a roadmap as to what to do. So let me erase that a little bit because that kind of got in the way there. So now that I can look at my bottom list here, I can kind of apply that quickly to my next point. Oops, come on. So let's do 8 comma -12. I can simply look at the bottom here and say what to do. So times the y by -1. So 8 comma 12 times the x by -1 and then swap them. So 12 comma -8 and then times by 2. So 24 comma -16. Okay. So once I have it listed down here, I can just kind of breeze through the other two pretty quickly as long as I got my list right. So times the y by -1. Let's see here, times the x by -1 and then swap. That's this one right here. Times the x by -1 and then swap. So -2, -10. And then multiply both of them by 2. We get -4, -20. So again, having a little roadmap on the bottom is sometimes a good thing to have. Now, there is a way you can do this differently. And for some people, this might be better. You can kind of map out what your transformation is going to be using the general point x, y to begin with. So let me show you what I mean. So say we have these 2 points, and we want to translate them by 3, 4, and then rotate them 90 degrees counterclockwise. Okay, so I'm going to take the general point x, y. So x comma y, no numbers yet. And I'm simply going to apply these transformations to this general point here. So translate by 3, 4. That means I'm going to take x plus 3 and y plus 4. That's what translating does, right? You add 3 to the x, you add 4 to the y. Then I'm going to take this and rotate it 90 degrees counterclockwise. Let me write this down here. Whoops. So rotating it 90 degrees counterclockwise means you're going to take the y value, which is this entire thing, times it by -1, and then swap your x and your y. That's what a 90 degrees counterclockwise rotation is. So that's going to be, whoops, -1 times y plus 4. And then over here we'd have x plus 3. Because remember, -1 gets times to the entire y coordinate, which are both of these things together. Now, this basically gives me my roadmap to my transformation. So instead of applying both situations to both points, I can simply say, okay, this is point A. What I'm going to do is I'm going to, for my x coordinate, take my y value, add it to 4, and then multiply it by -1. So this one would be -1 times 4 plus 4. I simply take out the y variable and put in the y variable I have. And over here with the x, it'd be x plus 3, right? So it'd be 2 plus 3, which gives me, let's see, that'd be 8. So it'd be -8 comma 5. And then I do the same thing for the b. 10 is my x, 8 is my y. So the first point is -1 times the y plus 4. So -1 times the y plus 4. And then here is the x plus 3. So the x plus 3. And I get -12 comma 13. So again, you kind of use this final point here as your general point as your roadmap to quickly apply the transformation to all 3 points. I find that this works better if you have lots of points you have to do it to. If you have just a few points you have to do it to, then maybe just doing it the other way we did is fine. But this way seems to be quicker when you have lots of different points like A, B, C, D, E, F to do this to. Now again, this is just a second way. You don't necessarily have to do it this way unless you're required to by your teacher. But this is just another method to help you in case the first method didn't sound too good. So let's try to do this one more time here with 3 different transformations, which is more common, right? So first off, 270 degrees counterclockwise. Let's change that right away because we don't normally think about these as 270. 270 degrees clockwise is 90 degrees counterclockwise. Remember, so that's something we did about rotations. 270 degrees one direction is 90 degrees the other direction. So we're going to use the general point x, y, and we're simply going to apply these one after another to that general point. So the first thing is 90 degrees counterclockwise. So 90 degrees counterclockwise means I'm going to take my y coordinate and times it by -1 and then swap. So that would be over here, -y, comma, x. That's the first one done. Reflect over the y-axis means I'm going to take my new y-coordinate, because remember, I'm referring it to this point, so take my x-coordinate. So reflecting over the x-axis means x times -1. I think I said that wrong again, so let me reset here because I'm tripping over my words. Reflecting over the y-axis means you take the x times -1, right? That's what a reflecting over the y-axis means. So I'm going to look at my point right here. I'm going to take my x value, which in this case is -y. I'm going to times it by -1. So that would give me y comma x. And then translate by 4, 5 means I'm going to add 4 to the y, or to the x coordinate, and subtract 5 to the y coordinate. Again, even though these values are swapped, the first value is still considered your x value. The second value is still considered your y value, or I guess you should say that your y spot. So y is in the x spot, x is in the y spot in this case, but that doesn't change the fact that this gets added to the x spot, this gets added to the y spot. They don't change just because the variables change. So this would be y plus 4. This would be x minus 5. So this is, in the end, what my values are going to end up being. So if I want to apply this to point A here, I would say 4 comma -6 would change into, okay, y value plus 4, so -6 plus 4, x value minus 5, so 4 minus 5. And I get -2 comma -1. I do the same thing for B and C. Let me try it 2 more times here. So y value plus 4, so 8 plus 4. X value minus 5, so -2 minus 5. And we get 12 comma -7. And then same thing for C to finish it out here. We get y value plus 4, x value minus 5, and we end up with -8 comma -15. And those are our 3 values, or 3 points, I should say. So again, the main thing to note here is that when you're doing this method, always remember that just because your variables might swap because of rotation or something, doesn't mean that your x and y spots have swapped. So in this case, -y is in the x spot, positive x is in the y spot. So when I reflect over the y-axis, I'm going to multiply the x spot by -1, not the y spot. So don't get confused by where the variables are. That's why in some cases, maybe it's better, instead of doing x and y, to put in a and b. That way you don't get confused about which one's your x spot and which one's your y spot. The only thing about doing that is that you have to remember that your first point is A and your second point is B in your original. So again, you can kind of tweak this method to fit what suits you better. Or like I said, if you don't like this mapping out method, you can do it the first way we did, which is just doing each transformation one after another, and then maybe writing a little roadmap on the bottom of your first one so you can kind of know what to do for your next two. Anyway, that's it for this video. Hopefully helped you out. If you have any questions, let me know. Otherwise, have a good day.